Hey, what's going on, guys? CodeMakerKings here. In this video we're going to be generating pre-calculated night attacks using Bitboards. So just like it was in the previous video when we were generating the attacks for the pawns, it goes literally the same with the knight. So let's say we have a knight on the square e4. So I will now be using the black pawns, not as the pieces, but just to show the places where the knight is about to attack, basically. So we only need to calculate the appropriate offsets for every given square here. So assuming the 8-to-8 board, and depending on board endings, this might be a little bit different, but in general it will have, so if we had 7 and 9, or on the contrary, doesn't matter really, offsets for the pawns, then in order to calculate this for knights, so let's say here it would be 8, here it would be 16, so 17 or 15, both in plus direction and in minus direction. But it's first we're supposed to be using the bit shifts. This would be the left bit shift and the right bit shift respectively. And so we have 17, 15, then we have 8, 9, 10, and 8, 7, 6. So 6, 10, 15, and 17 to the one direction and to the opposite direction. So that's quite pretty simple. And also obviously we need to take care of the off-board handling the attacks that possibly might go off-board. So say if we have the knight right over in here, the only places it would be capturing would be these two places for a knight attack. So obviously we don't have an attack here, here, or here downwards. So I hope this is quite pretty clear. Now as far as I will start implementing the knight attacks within the code, I hope it would be much easier to understand, basically. So I'm starting with the code that we've written in the previous part, and let me quickly walk through this code because it's not really that much here, even if it might seem in the contrary. So one of the most essential things, we did define the unsigned lon data type as U64 to define whatever bitboard we want. We have the very basic 3-bit manipulation macros to get bits, set bits, and pop bits. We have our board NDN is being represented right over in here, and the corresponding squares being mapped within this enum statement. We define the size y for 0 for white and 1 for black according to this enum as well. We have a very basic routine called print bitboard that allows us to pre-print the 8-to-8 table in the console to have a visual representation of a bitboard. It's quite pretty easy stuff. And all this stuff is obviously available in the previous parts within this Bitboards tutorial series on chess programming channel. Also, we've defined a couple of constants to represent not a file bitboard. This is the decimal representation of this binary example here. So this is needed in order to take care of pawns capturing on the a file where this shouldn't happen really. So same for the h file. And we'll add a couple more for to cover like not HG file, so 2 zeros here would it be, and not AB file respectively for the knights, because you'll now see why basically this is gonna be needed actually. And here we got our pawn attacks array being initialized, and the function mask pawn attacks that we've written in the previous part in order to make use of it while initializing the pre-calculated attacks for our pawns, which is done here, so here in init libra pieces. So we will be continuing this by adding the logic of initializing the knight attacks, and also we'll obviously create the mask knight attacks function here. So that's the plan for this video. Okay, so let's start with defining our knight attacks. Sorry, here. One T is missing. Okay, attacks array, and we don't really need to make it for two sides because knight attacks doesn't depend on the side to move, obviously. So the only thing we need to take care of here is the square, basically. So, or I mean, like it's a bitboard that bitboard for every square. So here I did provide this bitboard just well, actually this is bitboard for every given square, and probably it would be better to say like, so this is the square, right? So square like this. Okay, so I create the variable with the type of u64 or unsigned long, and let's call this night attacks, and this would be the array of up to 64 elements, because we need to initialize attack for a night on every single possible of 64 squares on our chessboard. Okay, so the next thing to consider would be start implementing our mask night attacks function, and let's do this right over in here. So I say mask night attack, mask night attacks, yeah, and here I create the u64 function called mask night attacks, and it would only take the square as its argument, because site has already been mentioned, it doesn't really matter that much. And now we'll need exactly the same setup here, so we'll define the bitboard to represent the available attacks for a knight on a current given square. Also we'll have a bitboard where we'll be putting our knight to generate attacks for it using the offsets, and actually we're setting the kind of this knight on this temporary bitboard to later on use it for bit shifting to generate the appropriate attack. So I just copy this part. Oh, I'm sorry, not cut. Just want to copy this part and paste this right over in here, and eventually we need to return the result stored that would be actually stored attack for knight on a given square. So we would be returning this knight attacks. We would be altering this attacks bitboard, and eventually we'll return it when everything is done, basically. And here we just need to generate knight attacks, assuming obviously that the attack is not going offboard, which I will cover just right in the moment. So we literally need to take care of all the possible offsets using the bit shifts. So if I can simply say like attack bitboard to be bitwise ORed with our bitboard where we've just set up our piece. So well, probably let me just try to show you this. So if here I just printf, sorry, my I can actually say print bitboard, right? Print bitboard, and this bitboard that we're using to set the knight on. And if I just try to run this, let's say mask knight attacks, okay, and let's use the square of d4. So now we should see a d4 square being turned off to 1, while all the other squares would be zeros, which means that there is a knight occupying the d4 square. So in order to compile this stuff, I need to say gcc bitboard.c-o bitboard, and if it compiles, I want to run the bitboard binary executable. Okay, so just as expected, we have this bit set to 1 at the square of d4, because we did set this to d4. Let's say we make it to, I don't know, like c3, then respectively we have the knight being set up right over in here. Okay, so let's get back to d4 basically, and now I just want to show you this. So what's gonna be happening with our attacks, and okay, just let's try the very first shift, the shift to, well, let's take 17. Okay, and save. Okay, no, not the attack, but attacks. And also, yeah, also obviously we need to print. Actually, we need to print this. So print Bitboard, because again, like this mask night attack returns the U64 integer, which is the type of Bitboard. So now we probably would have, yeah, two of them. So here first we have where the knight is actually being set up, and so so this is oh no, sorry, this is the attack already. Or hold on a sec, again C4. Okay, where is this? Okay, so this is where the knight stands. Okay, let me just switch. Let me just swap them within their places. Or hold on a sec. How would it be better to do this? You know, like I will probably cheat a little bit, and instead of printing this right over in here, I will just be printing the Bitboard like this. So print Bitboard, and let's just take the 0 on Standalone loan, just the empty Bitboard, and shift this to 17. No, sorry, and we need to set bit and 0 unsigned loan and the C4 square. Okay, let me just check this out first, so to make sure. Okay, let's create U64. Let's call it night and make it like this. Okay, and print this just here. Excuse me. Oh, just the wrong name. Print Bitboard. Okay, so here we got our knight being set up on C4. So this is what's happening here within the mask night attacks. But I just want to print this after the attacks, so that's the reason for doing this. Okay, here. So, and also, yeah, and now I just want to print the attacks for the C4. So here is our knight, and here where the knight occupies. So C4 goes right over in here. Okay. So this is the offset, right, shift bits to the right at the value of 17. Okay, perfect. So now let's test our off-board stuff. So if the knight is on C4, this is just fine here. So I hope that this idea is clear, that we have the knight on C4, and this is one of the possible attacks for the knight. So I will now just get rid of this Bitboard in order to. Just don't really want this to distract from the main gist, basically. So we just assume and remember that our knight actually stands on C4, but the bits that represent that would have been printed on the Bitboards are the attack bits. So it's where the knight kind of attacks. So just to bear that in mind. So if we have the knight on C4, we have one of the attacks. So now let's place this to B4. Okay. So let's place this to B4, and this is still kind of fine. So the attack is on board. But if we just place this knight to A4, then suddenly you see what a disaster is going to happen here. You see, like, it's trying to occupy the H file, which is incredibly wrong here, obviously, right? So in order to avoid this sort of this disastrous behavior, we need to do just the same thing we've done when we were generating attack for our opponent. So we need to bitwise end this attack with not H file. And if we have a look at this not H file, so this is it. So bitwise end on this number, this Bitboard, with this Bitboard would actually erase this bit, and that's the exact thing that we want to do here. So if you want some more detailed explanations on how exactly this works, please feel free to watch the previous video in this Bitboard tutorial series, on chess programming channel, where I'm covering the pawn attacks quite pretty extensively. Okay, so mask knight attacks. So here I just can say like if, and this bitboard right shift to the offset of 17 bits, bitwise ended with not h file. Okay, and now this should erase this current bit. Okay, perfect. So if we just drop back to b4, everything is fine. We got this, so we are on b4, we got this. But if we go to a4, we're not going off board. In our case, this is the h file, because from the computer perspective, it's not a table, it's just a 64 long bit string. Okay, so let's get back to our a4, and here we see like we're not going off board anymore. So perfect. Let's drop the knight back to d4 actually, and let's try to generate another attack here. So let's take the 17, the set of 17 bits, and oh my god, where are my pawn attacks? Knight attacks. So we need to say attacks. Attacks bitwise board with bitboard, and oh, this was 17, so let's now right shift to 15 bits. Okay, and now we already have two attack squares, right? So we are on d4, and now this one has appeared. So if we just go to g4, okay, it would still be just fine. So let's put a knight on g4. Okay, so now the knight is now on g4, and these are the attacks. So it's still on board, everything is fine. But if we just put this knight on h4, something similar as before should happen, and we'll see a misplaced bit. So in this case, we need to bitwise end our shifted bitboard, now our bitboards with the bits offset with a not a file constant, and not a file constant looks like this, and this is the number that represents this binary bitboard view in a decimal, in an unsigned long, as an unsigned long integer. So we need to bitwise end this with the end with a not a file. So here, if I just simply say if bitboard right shifted to 15 bits, bitwise ended with not a file, and let's go again, and you see like now we don't go off board anymore, which is absolutely great basically. So let's move further on actually, and now let's bitwise or our attacks with the offset of 10. So let's drop the knight back on d4. Okay, sorry, attacks, save, right? Excuse me. Oh my god, what has just happened? Is the offset wrong? Okay, just hold on a sec. Maybe I just missed the offset. So if we just take, so 8, 9, no, it's 10, it's right, 10 or 8, 7, 6. This is really strange. Like, what did I do wrong here? Oh, not 10. Oh my god, what I've done. Obviously, bitboard right shift to 10. Yeah, obviously I'm not gonna be doing this with bitwise or in with a constant of 10. So here is our bit when we shift the bits to the right, 10 bits. Oh my god, 10 bits to the right. The board is printed that way, so the direction of shifting the bits it's not the same as it happens on board, but that doesn't really matter that much. So now let's try to move our, so now the knight is on d4, let's try to move it to c4, and in this case everything is still just fine, right? But let's say we put this knight on b4, on now it's on c4, right? Yeah, let's put it on b4. So if we just put this on B4, we see like it might go to H file. So you might wonder that we need to say like again like not H file. But if we just put this to A4, in this case, you see that the bit is going even further to the G file. So we need to say not HG file instead of simply not H file. But we don't yet have this constant of not HG. We have only this not A and not H. So we need quickly to generate a couple more bitboards in order to actually get this constant. So let's make a simple loop. So let's say for rank is equal, for int rank is equal to 0, rank is less than 8, and rank plus plus, and the same I need to do the same for the files here. So int file equals 0, file less than 8, and file plus plus, and let's define the square that would be equal rank multiplied by 8 plus file. Okay, and now the condition. So we want to, well, let's first set bit, let's create some random bitboard here. So oh, actually do we already have this? So not A file, not H file. Okay, so we don't even have this yet. So let's create this not HG file and U64 not HG. So if you've missed the previous tutorial, not a big deal. This now we're doing something similar that we've been doing in the previous tutorial to generate this like bitboards with this like corresponding decimal values. So not HG file here, and for now it would be equal to just initialize this as 0 unsigned lon, and now we need to set this to not HG file, and the square is the offset, is the bit offset to use in order to turn the specific bit to 1. Okay, something, just put a semicolon. Okay, and we want to print bitboard and not HG file. Okay, so now we have all these files been set up to 0, but obviously we need only those, we need this last two to be set to 0. So in case if file is less than 6, because 0, 1, 2, 3, 4, 5, 6, 7. So that here file equals to 7, here file equals to 6. So anytime one file is less than 6, we need to set this bit equal to 0. So we say if file is less than 6, and now we get our bitboard being generated. So let's first grab this visual representation to give an idea of how exactly this kind of works. Okay, and just paste this in. Okay, so quite pretty the same as the previous time, and also we'll use this constant. So this D means that we have a decimal number, so it's not a part of the number itself, and this is printed in the C programming language in case if we specify the unsigned lon. So if this was signed, it just prints a minus here. So just ignore this D, and this is the number we need to take, and this number is the decimal representation of this bitboard. Very simple stuff. So we need just to paste this number in here, and now we can already use this within our night attacks, in our mask night attacks function. So I can say if and bitboard shift to the right 10 bits and not HG file. Okay, in this case we have we have this stuff. Okay, now I just want to comment this part out for a while because we don't really need this, and this one as well. And let's print the bitboard mask night attacks. Okay, sorry, before HG file. Oh, not HG file. Forgot the underscore here. Okay, I just forgot where the night is, and I'm just wondering. Okay, hold on a sec. Mask night attacks A4. Okay, A4 is right over in here. Yeah. So okay, let's get back to C4. Okay, so we didn't yet cover this one. So yeah, if we now go to B4. So the bit doesn't go to H file, which is good, and if we go to A4, the bit is not going to G file, which is also good. So we done it basically, but we didn't yet set the redshift to 6 to 6 bits attack here. So let's go for it. First, let me just drop back to T4. Okay, so now we'll cover this bit. Okay, so here I can now say attacks bitwise equals or bitwise or equals and bitboard and right shift to the last offset of 6. Now it should print this bit. Okay, so now the same stuff happens but regarding the A and B files. So let's go to say F4, and here we're still on board. Okay, but if we go to G4, okay, we'll now find our bit on A file, which is wrong, and if we go in even further on H file, we'll have our bit on B file. So here we need to bitwise end with a not AB bitboard, the subset to check this with bitwise end not HG, not AB bitboard. So now let's create the not AB bitboard here, not AB bitboard constant, and say not AB file, and here U64 not AB file equals to 0 unsigned non1. And here I just want to run this stuff again, and let's print the bitboard not AB file. And here, well, let's start with setting up all, sorry, not AB file. Let's start with filling all the zeros, and now we need to fill zeros only in case if file would be more than 0, 1. So if file is greater than 1, only in that case we want to print our set our bits equal to 1, otherwise they would be equal to 0. So this is the exact bitboard that we need to use as not AB file constant here. Okay, so not AB like this, and okay, and also the constant itself in decimal is this, like, so just copy, okay, and paste, save. And now here we can say if bitboard shift to the left on 6 bits, bitwise ended with not AB file. Okay, in this case we have we make sure that that the attack is on board. So let's so we probably we won't need this stuff anymore. So let's mask attacks on our H4. Sorry. Okay, so now here on our H4 we don't have any bits getting on A or B file. So the same if we just go to G4. Okay, so the very last thing we need to implement here is just to have exactly the same attacks, but for the opposite direction, for the opposite bit shift direction. So we've been shifting bits to the right to get an offset. Now we'll be doing the same but to the left. So in order to do this, we can simply grab what we already have here. Okay, copy and paste in, and now I just need to switch this bit shifts to the opposite side like this, and obviously the same here when we actually generating our attacks like this, and switch this A to H and HG to AB. So just shift them with its places. And now let's give it a little test one more time. So now we have all our attacks been printed. Now let's try to put this, to put the knight, well, say on A4. Okay, so only this attacks. Nothing is coming to H or G. Good. And now let's put it on H4. So the same, nothing goes to A or B file. And even more tricky stuff, just to give a nice visual representation. So let's put this on A1, save, and we have only these two. And if you just save, put this to H1, okay, we have the same A8, H8, here 2 attacks, and A8, 2 attacks here. So we're now ready to initialize our knight attacks array. Finally we are actually ready for doing this. So right over in here where we initialize our leaper attacks, we can simply say init knight. So actually init pawn attacks. Now I can just simply say init leaper attacks, because these all are the leaper pieces. So I can say, like, leaper pieces are those that are not sliding. So they are pawns, knights, and kings. So here I can say knight attacks, which is array of up to 64 bitboards. So we're indexing this by the square within this loop over 64 available square. And now we would be generating the attack mask for every single for knight being put into every single square from A1 to H8. Mask knight attacks, okay, and only the square here. And I'll just let's provide a quick driver to so print knight attacks on all the squares. So I can simply say for in square equals to 0, square is less than 64, and square plus plus. And here we just want to print the bitboard, and we want to print the bitboard of knight attacks index by the square. Okay, so I just want to clear my console to be able to scroll to the very top of the output, and now we just compile and run this. Perfect, it seems like it's already working. So let's have a look. Now we got our knight on A8, okay, and then we're moving this knight to okay, so is this still on A8? Excuse me. So A8. Oh my god, this is the output from the previous part. I'm sorry guys. So this is the valid output. So knight on A8, okay. Now we have the knight on B8, only 3 attacks, good. Now C8, we have 4 attacks, and now we just shift the knight, okay, shifting the knight again, Okay, only 3 attacks, so no off-board stuff. And finally h8. Then we move in our knight to a7. So this is how the attacks looks like. Okay, so 1 2 3 4 5 6 attacks already. No off-board stuff, just moving the knight. Okay, now it goes to a6, and we literally go, yeah, so here we already have all the attacks available. Now we go through all the possible square the knight is shifting, and the attacks are defined appropriately. So these bitboards we're now looking at are known as pre-calculated knight attack tables. So we can reference, so let's say we have a knight on a current given square, and we want to generate the moves for this knight, so we can just reference this we can reference this knight attacks table indexed by the square where the knight is currently standing during the game, and we can already get the indices for all the possible moves where the knight can go, and then it would be just a matter of distinguishing whether it captures the opponent piece, going to empty square, or if it would try to capture its own piece. Obviously that move won't be allowed. But how exactly to generate the moves for knights, assuming the Bitboard implementation, would be covered in the next video. So this is it for this video, guys. So I hope this was quite pretty clear. I hope you learned something interesting out of this tutorial. Okay, I'm just checking if everything is correct. Yeah, it seems like so. Knight ends up with the h1 square here. So yeah, the next video would be dedicated to generating king moves, which is quite pretty the same as the generating of the knight moves. The difference would be the offsets, and we would be bitwise ending them only with H or A file, because king is not going over 2 squares. It does during the castling, but it's not the matter of attacks anymore. The castling moves are handled separately, not within the attack tables, not within the attack tables at least. Well, okay, so yeah, I hope this was quite pretty clear. If not, please feel free to leave your commentaries below this video, and I would be happy to answer those commentaries, giving a more extended explanations if something is unclear. So this is it from my side, guys. Thanks for watching. Until the next time, and take care.